Hi, my name is Rishi, and today we'll be talking about basic factoring. Factoring is also known as the reverse distributive property. So in factoring, we're finding a common factor of two terms and then removing it from those terms. Okay. Now, what are the uses of factoring? Well, factoring is going to help you with solving quadratic equations. So in the future, when you're going to solve quadratic equations, this will be really helpful and will make the process a lot easier. So let's get right into a practice problem because I'll walk you through it and it'll be a good learning experience. So 5x minus 25. We're going to start with this easy problem and then we're going to slowly work towards some harder problems. So the first step is to find the GCF. Now, GCF stands for greatest common factor, and it means that it's a factor that when you divide the two terms by, in this case 5x and 25, so when you divide these two terms by that number, you're going to get an integer. So for example, if we take two terms, for example 10x and let's say 30, then a factor would be a number that when we divide them, we're going to get an integer value. So if I divide both of these by 2, I'm going to get integer values, 5, and then you have your x, and your 15, right? So these aren't rational numbers. Well, they are rational, but they're also integers. So the 2 is a factor of 10x and 30. That is a true statement, and you could say that. But what if we want to find the greatest common factor? Even though 2 is a factor, it's not the biggest possible one. If we divide both by 10, we'll get x and 3. So we still have integers because we have a 1x and 3. And the 10 was greater than 2. So 10 is our GCF. Okay, so now that we know what a GCF is, let's work through how to find the GCF of numbers. So when we have 5x and 25, and whenever we're factoring, we want to look at the integer parts of all the terms. So in this case, we have 5 and 25. Now, one good rule to remember is that your GCF cannot be greater than your smallest term. Or your smallest integer. So in this case, you have 5, so your GCF is going to be less than or equal to 5. Because if it's greater than 5, for example, if it's 6, then we would get a rational fraction. We wouldn't get an integer. So now that we have these, now that we have a parameter for our GCF, we're going to list out our possible options. Okay. So these are our options for the GCF. So the second step is to list out options. Now, I'm going to work backwards here because it's going to be a more efficient way. If one of the greater factors or greater numbers ends up being a GCF, then I'm going to get to it quicker. So let's see, does 5 work? Well, when I divide these terms by 5, I get 1 and 5. So it does work. So that way I know that 5 is my GCF. So the GCF is equal to 5. So that means our third step is to work from greatest to least. Now that we have our GCF, the process is really, really easy. So all we have to do is divide our two terms by the GCF. So the fourth step is going to be divide terms by the GCF. So 5x over 5 and 25 over 5, we're going to get x drop down this minus sign, minus 5. We're going to put that in parentheses, and then we're going to take out our GCF. So we're going to put that 5, our GCF, out of the parentheses. So our fifth step is to take the GCF out of parentheses. Okay, so now that we have this, I want to show you why we call it the reverse distributive property. When we distribute the 5 to the x and the 5 inside the parentheses, we get 5x minus 25, which was our original expression. So we noticed that these two equations are equal. So what we did is that we just took out that 5 from the original expression. So instead of distributing it to the two numbers and expanding it, we condensed it. So now, let's work through some more practice problems, and they're going to be just a bit more challenging. I'm going to choose a new color. Okay. So our next practice problem is 7x plus 77x plus 49, and we're going to factor this. So when we're factoring this, we can either combine the 7 and the 7x, or we can do a little bit of an easier way. So our first step, as we have on the right side here, is to find the GCF. Now, remember, our GCF can't be greater than our smallest integer that we have. So the GCF has to be less than or equal to 7. So in this case, let's list out our options. 7, 6, 5, 4, 3, 2, 1. And now we're going to work from greatest to least. So does 7 work? Well, when we divide all of them by 7, we get integer values. 7 over 7 is 1, 77 over 7 is 11, and 49 over 7 is 7. So 7 is indeed our greatest common factor. Now that we have our GCF, remember it's super duper easy from here. We're just going to take that expression, so x, drop that down, plus 11x plus 7. We're going to put that in parentheses, and then we're just going to take our GCF out. So we're going to take the 7, which is our GCF, out. Now, if you notice something, we have an x and an 11x in our parentheses. Since those are like terms, we can combine them. So we'll get 7 times 12x plus 7. Now notice how combining the x and the 11x at the very end was easier than combining the 7x and the 77x at the beginning and then having to find a greatest common factor. Doing it at the end just makes the process a lot easier. So that would be our answer. Now we're going to do one more practice problem. Okay. 4x plus 8y plus 24. Now, even though you see two variables, x and y, don't panic because it's the exact same process as we used before. So now what we're going to do is find our GCF. So our smallest integer that we have here is 4, which means our GCF has to be less than or equal to 4. We list them out, and now we work backwards. Does 4 work? 4 over 4 equals 1. 8 over 4 equals 2. And 24 over 4 equals 6. So 4 is indeed our GCF. So now that we know our GCF is 4, let's divide our terms by the GCF. So when we do that, we get x plus 2y plus 6. We put those in parentheses and take our GCF out, and we have our answer. 4 times x plus 2y plus 6. That is our factored form of the above expression. I really hope this video helped. And if you enjoyed it, please leave a like. Thank you.